Recording. Awesome. Hello, everyone. Thank you for coming to another session of the iSight NLP seminar. We have Waleed Ammar today. Waleed leads the Semantic Scholar APIs effort at the AI2 Institute. Before rejoining AI2, Waleed was a senior research scientist at Google, where he helped develop transformer-based models for generating DNA sequences and more robust task-oriented dot systems. Waleed actually gave us a talk at ISI 5 years ago, and it's super exciting to have him back again to actually give a talk on how we can actually tame the scientific literature, which is very necessary at this moment with all the papers coming out on a daily basis. So we're super excited about his talk. Without further ado, let's welcome Waleed.
Great. Thank you so much, Justin. You've been an amazing host so far. And yeah, very grateful for the invitation. It's great to be back here. And especially that I'm talking about something that, I really care about. So much so I, left the I2 for some reasons. And then I felt like that's like my mission and I need to go back and continue working on that in different capacities. So happy to talk about that interesting transition from being a research scientist to being a product manager in a later conversation. This is not what the talk is about. This talk is about drinking from the Firehose of science, which is a metaphor, for like publishers are, taking your work and providing it to the public through this hose, right? And then our society is like trying to drink from that hose. And just like so much scientific publication coming out all the time, it's impossible basically to do this in a some mediation or some sort of like facilitation. So that's where Semantic Scholar comes in the picture. And what is Semantic Scholar and how can we help with that situation? So this is a very high level, like kind of like overview of what I'm trying to say for the rest of the talk. Semantic Scholar is an AI-powered research tool our team is building to provide better access to scientific literature. It's incredible how hard it was for me to write this, because like when you're inside the thing, it's hard for you to like think a broader way how to introduce it to someone who haven't heard of it before. But hopefully, some of you have already known about Semantic Scholar for a while. Our mission is to use AI to read literature and help guide and accelerate scientific progress. And with respect to accelerating scientific progress, I want to emphasize that, just accelerating progress is not enough. We have to guide it. We can't just let it, go as fast as we can, because we know that doesn't work. Katie's work on fairness is a good example of that. And the way we accomplish this is by combining research and engineering. That's very core kind of like value for us. Is we don't want research or engineering to be siloed. We think that we can achieve a lot of progress solving these problems by combining the research engineering. So another kind of like when we get into a little bit of detail here, it's not one tool. We think of Semantic Scholar as three different things, but they're very complementary. So there's the website that we started in 2015. So that was like smart navigation. That's what I'm calling it now. We used to just say Semantic Scholar. And more recently, I think a couple of years ago, we started Semantic Reader. So that's meant as a much better way for people to read papers than just reading on a PDF reader or viewer. So you can think of it as a PDF reader that has a bunch of features that help you as a reader of the scientific literature do your work better. And I'll give a few examples of how does that actually help you. And then the public API is, I'd say, it's the most recent addition to what we're offering. And it's been there for a while, but it was like in dark mode. If you know, you know. But now we're open. We're out of the closet. And this talk is about 4 things. So that was just like overview of Semantic Scholar. But this talk specifically, I want to start by talking about the river that is overflowing with scientific literature, and did this overflow of scientific literature result in common good or not? So we'll talk about this for a minute, and then we'll talk about how we have been building capacity to help in that respect. Since common good is actually one of the core values of AI2. So like AI2's mission is to do artificial intelligence for the common good. And so we take that very seriously. And the last part here is kind of like trying to instill hope and kind of like share with you how we're thinking about, like making a difference, a tangible difference, and how can you and other people help us in that direction. So let's get started. By the way, this was generated by Dolly, which I was impressed. Maybe you're not. I'm not a good artist, so I'm easily to impress when it comes to art. The river of science is overflowing. So this is an article from the NSF by Karen White. It's a really good article. I highly recommend reading the entire thing. But here I want to highlight just the top line here. This is the overall publication worldwide. And it's just, as you can see, it's going up. It's not slowing down. I think there's some, like, depending on how you count, you might consider that to be exponential growth or not. It doesn't matter. What matters is like we all know that it's way too much publications coming out all the time.
Just by the venue of conference or journal or
just number of publications.
Author?
The breakdown?
Yeah.
This breakdown is based on the affiliation, not the name. So like if I am affiliated with AI2, yeah, I would be counted as an American publication, which, most of my publications are American, even though I'm not.
So 3 million publications in 2020 for the United States, right?
Yep, that's the number that's the NSF is reporting, yes.
Okay.
No, for the entire world.
Sorry.
For the
Thank
entire
you for
world.
keeping me in check.
But you just said
The top line is the word. The blue line is the US. It's actually worth noting because I think there's a miss.
Okay, cool.
Can you see the entire slide?
I can see it. I can see that. Yeah.
Is that better?
We were missing out on the logo, so now you can see.
I don't want to cut off the wires, but
That's important.
So this is worth calling out because the blue line is actually right now like below the green line. The green line is China. So it's worth thinking about it. Since for a few years now, the number of publications coming out of China has exceeded the number of publications out of the US, which is interesting. And of course, you might question the quality or a lot of the Chinese publications are in Chinese, so I don't know how to assess quality. Max can. Anyway, it's overflowing. Sometimes when the river is overflowing, we just cannot stop it, right? Or we don't want to stop it even. And sometimes that's messy. This is from DRC, from Congo. And this is a solution that creative solution that people in the town came up with to be able to move from one house to another. So that's like we're adapting, right? And like we could even think about turning that adaptation into something beautiful that people come to see because it's so beautiful and it's a vibrant culture like Venice. So let's do that for science. So this is our game plan. And we started this in 2015. Let's ingest the publication data coming out of all the publishers and pre-publishers and a bunch of other things like aggregators. And then identify duplicates and new duplicates because we don't want to have separate pages for your paper before you published it on archive and after you publish it on ACL. And then we want to identify relevant details. So, some publishers will give you the details like who are the authors, what's the venue, what's the publication date. Not all of them, it's not consistent. There's a bunch of messy data in there. And feel no shame calling out the mess that comes out of the publishers metadata because it's kind of a pain and it sometimes feels like it's adding more harm than good and putting that in the middle. And then identifying relevant already over. I want to call out something here. The date and references and authors are very different things, right? So the technique, the methods you come up with in order to find the date is going to be from a PDF file, for example, will be very different from how you identify the references and how you link those references to other publications. And then will also be very different from what you do with authors. because names are hard, especially Chinese names.
This is for publications around the world in different languages.
We're focused on English right now, so this talk is going to be primarily about English. But I want to say that everything I'm talking about also applies to Chinese publications and other languages. Just we haven't built the capacity to address those yet because it's a hard problem. But yeah, if other people want to help, that'd be great. Putting all papers in the same format is the next step. So once you extract those relevant details that people actually want to know about publications, you'll then want to put all these papers in the same format, like a JSON format, whatever it is, and then provide maximal access to our society to benefit from those publications.
Quick question: are you open to questions during the talk?
Clarification questions are okay, just because I want to leave 15 minutes at the end for in-depth. Is that okay? Cool. Thank you. And this is so we've been working on this for a while, right? And you think, why are you not done? But it's a hard problem. All of these things are hard. Even the last one is not straightforward, because if we solve all of this and we make it accessible to everyone, there's legal problems with you cannot actually share everything, right? So we have to limit ourselves to the legal constraints, but also then we're still getting this water. It's just it's it's nicer, but you're still getting all of them. So how can we allow you to filter to make some kind of smarter or more efficient way of identifying the areas within this immense literature that you actually should be looking at? So we're doing a bunch of work on this angle more recently. So since last year, this is some highlights of what we've done recently, I guess. So on the PDF processing side of things, we've done a lot of progress, in error reduction, entitled abstract extraction, citation detection, finding the links between the citation and the bibliography within the paper, and then bibliography parsing. So this means identifying what are the different fields in every entry in the reference section, and then literature graph. So building the entire graph and making it actually coherent, right? So you don't want duplicates. You don't want people whose first name say is published with just maybe I have just W for some publication and Waleed for another publication. So we don't want these to be different authors. So we need to do some author disambiguation there. And then there's lots of people who are called Max Man. So you would have to figure out which is which. It's a pain. Thank you, Max. It's all your fault. Affiliation normalization is similar to some extent, where we have a lot of affiliations, and sometimes a lot of times people are not consistent about the way they are using the affiliation. And then how do you count different locations for the same affiliation? Are we counting them as one or not? So that's another problem that we've been working on. Venue normalization is also along those lines. And then public API. I mean, clarification questions are okay. There's a quick clarification thing.
No, it's not quick.
Public APIs. So the public APIs is what I'm most excited about these days. And I'm going to spend a lot of time in this talk talking about it. So just quickly, I'll say that we've released it in a beta mode last year, and we're seeing exponential growth in its usage.
Quick question: what is it? Public APIs.
I will talk about that in a minute, but it's broadly speaking, it's providing access to this literature that we've been talking about, how we nicely made all the papers available in the same format. Now we want everyone to have access to that, right? And you think that's easy, but it's not.
I don't think so.
Okay, so this is just one of many examples for where the research and engineering collaboration helps. So this is a paper we published a few years ago, and we need to extract structured data from this paper PDF. Right? That's like one of the key problems that we need to work on. What exactly are you extracting? It will vary for different projects, but let's say this is what we're extracting. We're extracting titles, authors, abstracts, and sections. So that's the input, and that's the output. So you have like the actual PDF file as an input. So one standard way of doing this is like take all the strings coming out of the PDF, put them through a transformer model, and get word level classification. So train the model so that it will spit out title, author, abstract, and that kind of works. A better solution we found is to actually take into account the 2D dimensions. So where is this word in the PDF? We know that. Like our PDF parsers like always tell you where is every token. And when you have that, you can augment this embedding that you have for every word. So CLS is just like a starting token. And then construction is the first word. And instead of only representing construction as this embedding, word embedding, that might come out of transformer or whatnot, this can be augmented, appended to that embedding, right? And that's an embedding of the position. So that's the 2D position embeddings help. We've got a 2% macro F1 improvement. Stuff like this matters because they immediately correspond to things like how many people are calling us or like sending us emails like, why did you mess up my paper? It's a real thing. So this is like, I don't remember what was the error rate, but like if it's something like 8, that would be 25% less errors. And then
Actually, with regard to that, since you mentioned it, why don't you allow people to contribute more? Like, wouldn't it be just an easier task if you like something like Google Maps or Wikipedia, where it's like volunteer based, and you see a mistake with your paper, you edit stuff, and like.
So we definitely do that to some extent, but it's not straightforward. So we don't do it for all the fields. So one very critical thing is the author. Not author affiliation, the author connection with their paper. So you have an author profile page probably on Semantic Scholar, and if you go there, you might find a paper that you didn't publish, or you might find that one of the papers that you are very proud of is not there. Like, what the hell? I want my papers to be right. So we have built tooling for you to be able to edit that, and we will review it. So somebody, after you claim your author profile, you will be able to do that, and somebody will review it. To make sure that you're not trying to claim Justin's paper. Yeah. Come on. We're on to you.
Or like make others review it before they can update their own paper. Like someone from a community, basically.
Yeah, I mean, do you want to sign up for that? Are you done with all your reviewing and wanna?
I mean, so that's one thing. But what I meant is like, if I want to update my paper, I have to volunteer to like review maybe 5 other updates proposed by other people before I can add my update.
Yeah, maybe it's a good idea. I think there's a lot of additional work I would like to see us do in terms of community moderation and like engaging the community and help. So I agree with you.
Yeah. Okay.
So the downside of this approach is that we have to do the pre-training. And the pre-training, like, sure, everyone does pre-training, but pre-training gets more expensive when you're like trying to upgrade to the latest and greatest LLM, like GPT-4 now. I don't know how expensive it is to do the pre-training, but I don't want to do it. And so we found a solution that works without the need to pre-train. So like out of the box, the newer, better, larger, greater, stronger LLM, you can use it out of the box, which is what we call Vila. And the idea here is we know that the text on the PDF are grouped in text blocks, right? So we will tend to have a block for the title, and then a block for the authors, and then a block for the affiliations or something else, right? It's not always in that order. Sometimes affiliation in the bottom, but there's like some not standard, like typical groupings of the text, and that notion we can learn. So we came up with that approach of basically integrating the modalities. So we know we have the 2D locations of all the words. We can group those words and find that these belong to the same block, and then we can insert just a token in the middle that indicates that this is a new block. Your model should be aware of that, and that makes a big difference. So it doesn't require. So comparing this to the pre-training with the 2D with the like the 2D embeddings, that doesn't help. So it gives you similar results to what you would get from just having the 2D embeddings. But what really matters is like we can eliminate pre-training, which is a huge advantage. Here's some results for how that actually translates into numbers. And the next thing is this is good, but we still need to do this for multiple tasks. So how can we do this more efficiently? And a lot of the engineering work needed here has to do with like how do we do embedding recycling? So you've built a model for one task and you want to use it on other tasks. So like, how do you cache your intermediate representations in a way that is efficient, that is going to work from the modeling perspective that will give you higher quality for the tasks that you care about. So that's another idea that, I mean, it's definitely not a new idea, but like employing it in this fashion was new. And we've seen like significant speed ups with very minimal losses in performance and accuracy. Okay. Now I'm going to switch to the second part of the talk, which is how did this scientific progress we'll be talking about bring common good? And I love this figure because it shows that the answer is nuanced, right? It's not straight yes or a straight no. So if you think about Europe, yeah, our ability to understand the diseases and the dynamics of how different cell functions work and how they are affecting our ability to live, and how can we make interventions, either surgical or like chemical, that improve the function, have significantly increased our lifespan and made a lot of people live better by eliminating some of those diseases. It's a very tangible way of like quantifying the common good aspect. Not necessarily the longer lifespan, because like who knows, maybe a shorter life that's fulfilling is better than a longer life that's less fulfilling. But just having fewer diseases, like when you're at 30, right, it matters a lot. At the same time, it shows that these lines are not tracking in the same way. There's a big drop here, which I don't actually quite understand what happened. But clearly, Africa is quite a bit behind. And, we're slowly catching up, but it doesn't look like we're doing great. And it's not like I don't expect us, without changing the way we do science and execute science and translate their scientific results into action, I don't think we're going to catch up. We'll find out, I guess. But the point I'm trying to make here is the answer to this question will depend a lot on who you ask. If you ask somebody who can benefit from cancer therapy and have the means to get it, they will be happy about having that science that backs that treatment. If you ask somebody who wants to be able to climb mountains through the end of their life, that's great. It's actually one of our partners for the API. So Gladden Longevity uses our public APIs to provide timely and accurate and state-of-the-art recommendations for people to live better in their older years, and that's great.
I'm sorry, Semantic Scholar APIs?
Yeah.
So like they recommend papers?
They do recommend papers, but more so their customers are more interested in like specific advice. So they will give the advice to the customer based on scientific evidence on how they like choice they can make in life. Do I drink this glass or not? Stuff like that. I mean, it's more complex. It's often more complex than that. But in order to get the correct information, and stay up to date on the areas where they care about, they are using our APIs to stay informed in those like specific areas. Because API provides not just like access to the literature, but also ways for you to filter and get like recommendations based on some, like prior examples of positive and negative examples, things you care about, among other things. But if you ask people in Seattle who are, unhoused, and there's a lot of unhoused people in Seattle, a lot of San Francisco and all in a lot of big cities in the US. Or you ask this lady trying to like get water to her house, like by walking, I don't know, an hour, or this person in Mexico is trying to also get water for their business or their house. I don't think they would say that science, like the scientific progress, has like made their life a lot better. I would say it exacerbated the inequalities that we have. So as science, we work on the problems we care about, right? Like you think about like all these things I could work on. What is the one that I care about the most? Or also like what is the funding? But we apply for funding, so we apply for the things we care about. And another graph from the same article that I really appreciate having this data. It shows how like the amount of publications that come out of high income economies. So these are countries, like by economies here, they are referring to countries. And so everyone in the US will belong to high income, even though not everyone in the US is high income. And then there's upper middle income, the red line, and then there is lower middle income, the flatter line. And yeah, please.
So like the countries were divided by income groups at 1996, or does they change groups?
It's a great question. I don't know the answer.
Mm-hmm. Okay.
Very interesting.
Yeah.
We'll have to go back and read that carefully. Another thing I want to highlight, I guess, so the reason I'm bringing this up here is this is kind of a key point in understanding why science progress have benefited some, but not everyone. We work on the problem we care about. If you care about rich people problems, you're gonna solve rich people problems, and rich people will benefit from that. And then, like poor people will not. And it's just like, of course, then the inequalities that we have will be exacerbated. The other thing I want to highlight is it's not like anyone's. So there's no one person or one organization's job to fix the inequalities. It has to be like everyone interested in that pitching in. It's not something that we can just export, like let the UN deal with or Gates Foundation deal with. It has to be something that we individually care about for it to make a difference. And of course, like realistically speaking, not everyone will be able or willing to do that, but the more the better. I guess is a point I'm trying to get here. So how can we help? Like in Semantic Scholar, how do we decide to help and bridge this inequality gap? There's a few things that we're doing, and I will first review them, and then like we'll highlight one of them as the primary thing I want to focus on for the rest of the talk. So building our capacity to help scientists. This is something that's general. You can build this capacity and then like focus only on the rich countries. That's one option, right? So by putting all papers in the same format, by providing public APIs, we're building our capacity to help. The second one is consider common good when solving technical problems. So this is about understanding how the problem you're currently solving can be done in a way that will exacerbate the inequalities, for example, to the queer community or to the Jewish community or to the Muslim community, and from there, like try to make better choices about the way you're solving the problem. Maybe how are you giving this work to crowd workers? How much are you paying them? It can be small decisions like this that have big consequences. And then the third one is to consider the common good when choosing what problems to work on. So recently we've been putting a lot of effort in understanding the accessibility needs of science. So like, if you're a researcher who is interested in building solutions for someone who cannot see, who's dyslexic, or who's has some like visual impairment, right? Visually impaired. We want to focus on that in our semantic reader. We want to be able to provide a better experience for people with specific accessibility needs. And then the last one is enabling underrepresented groups to participate in science more effectively. The reason I like this one the most, the reason I think this is the most impactful is when I talk to people, for example, in Masakana, I don't know if you're familiar with this group. It's a group of researchers and engineers who care about NLP in Africa, and they are thinking primarily about like their interests, like African community interests. And they don't actually care for the first three very much. They care for the fourth one a lot, right? They want to build their own capacity. They want to be able to sustain this ability to get better. They don't want to take stipend. They don't want to get help. They want to build their capacity to help. So this is why I'm thinking this is probably the most efficient, and it's the hardest one to accomplish. So public APIs is like part of doing that. Istolite is kind of like a light version, like that requires less internet, like smaller bandwidth for the internet, because we realize that our website doesn't load as fast in Africa, unsurprisingly. So how are we building our capacity? This is what I'm gonna talk about next. The slide. We're working on those three dimensions. The thing that I ignored last time is this is how we try to think about like the way people do work in science, just like a phase of discovery. It's never like completely different, but at any given time, you might be trying to reach new ideas, new publications you haven't heard of before. You might be trying to actively decide, well, of all these papers, what am I gonna actually read? Of all these things that come out of NLP last year, which ones I care about or want to go to the top for. And then like you want to read a paper in some detail, and that takes an hour or 5, depending on how much you care. And we want to enable those things. Like we want to build our capacity so that people can do these things more efficiently. And then there's like ideation and synthesis. So you collect a bunch of ideas from different papers or from different conversations, and you want to come up with a new hypothesis or a new idea that will address a certain problem that you care about. And there's the infrastructure, and this is where kind of like it's in the back. So in order to do creative work on any of these things, we need to have certain like infrastructure that's solid, and also important for opening it up to everyone outside here to be able to benefit and build on it. So from a bit of like summary of what we did last year, but it's a very unrealistic thing to cover everything. So I'm just like going to show the empty version of this table. So we have the research team and we have the product/engineering team. We try to build things that are going to address each of these steps or phases in the researcher's life cycle, process of doing work. And of course, a lot of it is collaborations, but oftentimes some projects have more of a research emphasis, as well as it has more of an engineering emphasis. And these are the things that we built or made a lot of progress on last year. So I'm not going to go through all of them, but I'm going to focus on the API, which kind of belongs to the tools section. So what kind of API are we serving? This comes back to your question. And so we have REST APIs. So it means you make a call, a get or post HTTP call, and you get a response like this. So if you type on your browser, semanticscholar.org, grab v1, autocomplete, and then you give it a query, Semantic, it will give you a bunch of publications that where the title starts with semantic, among other endpoints. So this is what we call an endpoint. And I think we have something like 44 endpoints now, providing all sorts of functionality to the users, which is summarized here. I forgot I have this slide. So roughly speaking, you can kind of like group them into paper-focused endpoints. So it's giving you paper-specific details. It includes search functionality for this, for like papers with certain keywords. And then there is one about author-specific details. So you can find, for example, the index of an author using this endpoint. And also things like, what are all the publications that this author wrote. You can also search for authors based on their names. And then there is, the next one is a recommendation system. And it's really like, it's a misnomer. I think we should call it a feed endpoint, because we're only sharing with you things that were published in the last 2 months. So it's like recommendations based on the recent literature. And we're working on a more kind of like expansive version of it that enables you to get recommendations from like things that were published 10 years ago. But a lot of times what we actually want is to keep up, like update your knowledge about this topic. And then the next one is our way of releasing data sets. So we have put together a number of data sets that people can just like bulk download and do whatever you want to do with this data. And then the last one is very experimental. It's, if you're interested in peer reviewing or building peer reviewing software, we would love to hear your feedback on where the friction points are and how to make it better. We use partner authentication, so most of our endpoints allow unauthenticated access to a certain limit, and the current limit is 5,000 requests per minute. If you want to get more than that, you will need to apply for a key and authentication, and it's not hard to get. It's just our way of throttling. The cool thing about that is we get to know who our users are, at least the users who need a higher limit, and I'm gonna briefly mention some of them. So recently, I was giving the board meeting updates for Semantic Scholar. I wanted to like actually get a realistic sense of like how we're doing. So these are some of the example, the partners that we are using. Sorry, partners is our way of referring to API users. So we call all our API users, we call them API partners. Anyone who has an authentication fee. We're close. And it's a long list, but what I want to emphasize here is we have a large number of Asian universities. Lots of North American universities only put a small subset. Also Europe, I tried to keep it short. The rest was more of a natural sample from my reading of the keys we give out. And we don't have enough from Africa. We don't have that many. Yeah, I'd say Africa is the biggest, the smallest, given the number of people who live in that country.
Sorry. Do you have any survey on what these partners you find useful? So what part of your APIs they use most?
Mm-hmm. Yeah, we actually reach out pretty consistently to our partners and ask them, hey, what endpoints to use? Also, we can look, but it's both are helpful. And yeah, I can give you some details if you care, but it's kind of a deeper dive, and we're almost out of time. Sure. So I will rush because I want to wrap up in say 5 minutes. These are kind of like model, I'd say like representative examples of our partners. So one of them is a founder of a startup that's building software for people to access the literature using our APIs as a primary source of data. And you might think of this as like, hey, why do you want to allow something like this? This might actually be better than Semantic Scholar eventually, and a lot of people go to connected papers. And that wouldn't be okay from our perspective, because our mission is to enable people access to the literature. If somebody else can do it better and we can just help them do that better, that is still consistent with our mission. The next one is a software engineer in blending longevity. Is the company I mentioned earlier. So I already talked about this a bit. And then we have a robotics researcher at NVIDIA, and we have a grad student from Penn State University, among many others, of course. I just wanted to highlight the types of users I see consistently using our. Most our partners think highly of us. So we have surveys, as I mentioned, and it's a recent survey we did. We got pretty good comments from how people think of the value they get from our APIs. But of course, like, who doesn't want better quality, right? We do make mistakes in our extraction. A lot of AI methods are not perfect, as we all know. So when you bump into this in your own work, you complain about it. You want to see improvements. I wanted to talk in some detail about some other projects we've been focused on recently. I don't think I have time, so I'm gonna just quickly rush through this. This is our current internal attempt to combine ChatGPT with Semantic Scholar. We're trying to highlight, the societal impact. We don't want to give false information, so we're putting a lot of effort in understanding how we can do this in a way that doesn't, make people make bad choices based on incorrect information. So factually, it's a big deal here, and we're not trying to publicize this broadly because we don't think it's ready. So there's a bunch of work that we're currently doing to improve the retrieval, improve the reasoning, improve the answering part of this tool. I'm gonna skip this in interest of time. This is, by the way, the semantic reader. So, for example, it allows you to click on a citation and you will get a card that shows what this citation is. And we can talk about this in one-on-ones. The last part, which I'm gonna do quickly, is there is hope in a more inclusive science culture. We're already seeing signs of that. So the same graph, you can see that the red line is catching up. It's accelerating faster than the blue line. The yellow line is flatter, so that's
it's
not
actually, if you just go logarithmically, it's actually quite steep, right? So it goes up quite a multitude, relatively speaking.
you mean the yellow one?
The yellow one, yeah. So it goes from 30,000 to over 240,000, so it's eightfold, which is not too bad.
It's not bad, but I would say
From the low, but the relative increase is quite encouraging.
right. What I would say is there's no hope if we stick with these rates. There's no hope for the yellow line to catch up. Would you agree? If we make predictions based on the past performance, the yellow line is not catching up.
It's gonna take a while.
The blue one double, the yellow one is up eightfold, right?
Maybe we can have a longer conversation about this after we stop recording. But I'm gonna skip this. One thing that I would love to hear from you, maybe in the 15 minutes after this, is which underrepresented and underserved communities should be prioritized. There's so many. So there's race and racism problems, even in our own small part of the scientific literature. NLP has been highlighted how intersection of accessibility and computer science leads to inclusive text. So this is something that we have been focused on recently, the accessibility component. And then there's languages, all these publications from in other languages, we do not have them. And more importantly, in my opinion, all these publications in English are critical for you to do science, even if you don't speak English as a first language. So how is that impacting you as a non-native English speaker, and how can we help? I think I'm gonna wrap up here. Thank you for having me.
Awesome. Waleed had so much to share, so it's a shame that we only had it for 45 minutes. But please do stick around because we will. That's the end of the recorded part of the talk, but we will definitely take the remaining 15 minutes to discuss. So, with the virtual audience, please stick around.